In this video, I'm going to take that unit circle that we constructed before using compass and straight edge, and I want to focus on just on these 45-degree angles that we created with these angle bisectors. So what I've done is I've traced just those parts of the unit circle onto tracing paper, and we're going to focus on just those for now. Eventually in your notes, you're going to want to have the 30, 60, 90 and the 45 on the same unit circle. But I think it can get really cluttered when we're figuring all this out to see them on the same unit circle, so I'm breaking it up into different pieces of tracing paper for these videos. Start by filling in the coordinates we already know. I know this is the coordinate 1, 0. This is the coordinate -1, 0, because if I go 1 unit, that same unit that formed the unit circle, this way, that 1, or this way 1, those are the coordinates I would get. And if I did that up and down, I would get 0, 1, 0, -1. So those are all the points I get for free. But I also want to know, for this 45-degree angle here, what are its x and y coordinates? So I want to find this point here. I know starting from here, this is a 45-degree angle. Because I know this is a 90-degree angle because I built a bisector, and then I did an angle bisector of that bisector, so it has to be a 45-degree angle. So I know this is a triangle with a 45-degree angle if I construct, and this time I'm going to cheat. I'm not going to actually use a compass to do it. I'm going to eyeball it. Just lining up the ruler with here. I could use a compass for this, and I did earlier. But from this point on in this video series, I am going to just trust my ability to freehand with rulers. I could construct a perpendicular line through that point. I could construct a line through this point that's perpendicular to this line. If I did that, that would be 90 degrees because it's perpendicular. And this would be 45 degrees because every triangle adds up to 180 degrees. I've already got 90 of them used up here. 45 plus 45 and 90. And I know my hypotenuse. I know that my hypotenuse is a length of 1. The reason I know the hypotenuse is a length of 1 is because it's a unit circle. Just like this is 1, this has to be the same length here as this was here. So now I can set up an equation to find this length and this length based off of knowing the hypotenuse. Thinking back to special right triangles, what I know is that if I have a 45, 45, 90 right triangle, I have that x root 2, I would get x and x. But I have 1. I don't have anything with a root 2 in it here. So I need to do something here. I need to fix this. Well, that means I know that my x root 2 is equal to 1. So x root 2 is equal to 1. And then I need to solve this for x. So I divide both sides by root 2. And I get that x is equal to 1 over root 2. And this is true, but it's not in its final form because we need to rationalize the denominator. We need to go ahead and not have something that's irrational, have a square root in our denominator. We want to fix that. We want that to be in the numerator instead. And that's just a convention, and it's one that we're going to be using consistently, which is that we're not done if there's still a square root on the bottom. The way to rationalize a denominator is to multiply by a special form of 1 of whatever the irrational thing is in the denominator over itself. This is just a funny form of 1 because anything divided by itself is 1. Any root times itself is the thingy under the root. So I have now fixed this, and I have 1 times root 2 is root 2. Root 2 times root 2 is 2. And so I know this length here is root 2 over 2. And this length here is root 2 over 2. So I'm going to color code each of those. This length here is root 2 over 2. This length here is root 2 over 2. And knowing those triangle lengths tells me what this coordinate is. This x distance here at this point would be, just like this went all the way to 1 but didn't go up, this went all the way to root 2 over 2. It didn't go up. So it's root 2 over 2 comma 0. Well, this one's straight up from that. It's perpendicular. So this has an x-coordinate of root 2 over 2. Similarly, this distance here went from 0, and we know it went up root 2 over 2 from 0. So this is also at root 2 over 2. So a 45-degree angle will have coordinates of root 2 over 2 for both. Well, let's look over here. I'm going to get a very similar situation over here. If I go ahead and I drop a perpendicular here from that point, I'm going to go ahead and do it in orange so it matches that color coding that I ended up doing there. Clearly, this triangle is going to have a lot in common with that one. I got it by bisecting this angle, so this would be 45 degrees. But on the unit circle, we talk about all angles coming from standard position most of the time. So this one is going to be 90 to get to there, plus 45 more to get to there. What's 90 plus 45? 90 plus 45. That's a 6. 45. 135. So this is 135 degrees to get to this point on my unit circle. Since this is still a 45-degree angle here, I will go ahead and write in yet another color. Since this is a 45-degree angle, and this is a 45-degree angle, and this is still 1, these lengths are going to be the same ones I already solved for. So this length here is still going to be root 2 over 2. And this height here is going to be root 2 over 2. But just like this coordinate was -1, even though this is 1 unit this way, all distances are still positive. But the coordinate, because it went root 2 over 2 units to the left instead of to the right, just like this was a -1, this would be a negative root 2 over 2 comma 0 for this point. And so it would be a negative root 2 over 2 for this point. My y-coordinate still went up, just like this one did. It didn't go down yet. We'll get there. So my y-coordinate will still be positive. It'll be root 2 over 2. So on my unit circle, I've now identified 2 additional points that are the halfway points between my easy ones. My 90 degrees were easy. These, I had to use these special triangles to find. And by some arguments with symmetry, let's figure out what the rest of them are for this little group of points here. So I'll just go ahead and draw these. And this would still be a right angle here. This one, I start here at standard position, went all the way around here. Well, to get this far was 180, so now I need 180 plus 45. That's 225. So this one is 225 degrees. I already know that's root 2 over 2. This is also going to be root 2 over 2 by the same arguments I've made before, so I'm skipping making them again. As a length. But this coordinate, now I went down root 2 over 2 on the y, just like I did on the x's. So this one's going to be negative root 2 over 2, comma, negative root 2 over 2. And I found yet another coordinate that's on the unit circle. I found my 4 easy ones, and 3 out of 4 of the ones where the 45-degree angles happen. This one over here, well, it's going to be just the same as the other ones. This time my x is positive because I went a positive amount on the x. So that'll be root 2 over 2. But my y, I had to go down rather than up, so it'll be negative root 2 over 2. And those are 4 more coordinates on my unit circle. Oh, I forgot to do what the angle measure would be for this one. Hang on one second. Should do that as well. So that would be 90, 180, 180 plus 90 is one that I probably should have done a video with those, but I didn't. So if you didn't already know that, 180 plus 90 is 270. So that's to get to the purple one. Another 45 to get to this one. That is 315 degrees to get there. So I have 4 points on the unit circle that I've found with my 45-degree triangles.